Welcome to a Consumer Franks podcast. In the first in a series of podcasts on aircraft cabin air quality, we shall explore what it's about and some of the problems in delivering cleaner air for passengers. I am Frank Breheny. Since 2006, I've had the pleasure to be involved with pilots, crew and passengers on the issue of cabin air quality. Beneath the ebb and flow of aviation and tourism commentary, there lurks an almost whispered scandal of international proportions. This scandal has its roots going back to the 1950s, when air travel was beginning its journey towards providing mass travel for all. Commercial aircraft were fitted with a new environmental control system called bleed air. When we get on board commercial aircraft, we experience those soothing lights, smiling faces, seating according to your pockets, refreshments from the basic sandwich box to an a la carte menu. But despite these differences in experiences, we all breathe the same air. I've seen over time many commentators talk about stale air, recycled air and those within the industry liken environmental conditions to being no different to being in your office or indeed your own home. What very few people discuss in the broad media is the story of how passengers, pilots and crew are breathing in a potential cocktail mix of toxins that come from the aircraft engines which cause serious health problems. Most people are completely oblivious to the fact that the air that they breathe on board is actually siphoned from the aircraft engine and passed through coolers and to a certain degree filters and introduced into the aircraft cabin and cockpit. That is bleed air. Bleed air was introduced as an engineering solution to reduce the weight in an aircraft by removing non-bleed air equipment, thus lightening the load. Whilst the subject is not hotly debated in open public forums, I can assure you that the aviation industry, their insurers and civil aviation authorities around the world are keenly aware of the potential of contaminated air in aircraft to disrupt an entire industry. All makes of aircraft are fitted with the bleed air system, with the exception of one, the Boeing 787 Dreamliner. Now, I'm certain that those in Boeing would not accept that the Dreamliner's introduction to our choice of aircraft is not as a reaction to this hidden debate, but as a recognition of that bleed-free technology along with the new technology of the Dreamliner. It produces quieter, more efficient and cleaner and therefore a more beneficial experience to passengers and crew. They would no doubt argue it's about creating a new choice for the industry and about giving people a choice about the aircraft they would like to fly in. But coming back to the bleed air models, they are still rolling off the production lines and conceivably, even if solutions are found for newer models, it is anticipated that the current stock of aircraft in service will be with us for another 40 years. That's 40 more years where passengers and crew will be exposed to the potential of contaminated cabin air. That's 40 more years where passengers and crew will report and add to the already mass of evidence of the ill effects of exposure. And that's 40 more years of ineffective regulation and enforcement of what little there is. To help you understand the state of regulation, it is best to describe the current state of regulation in Europe, but I will add the same issues are found throughout the world. It is not solely a European problem. Regulation for the production of aircraft, their operations, the operations of pilots and crew, cargo and baggage, and the carriage of passengers is held within a basic regulation. Now, regulation in European terms means that it is adopted by each member state of the European Union without the need for individual national parliamentary action. The basic regulation is extensive and it is referred to as hard law. In other words, it must be complied with. But basic regulation differs too and is supported by For example, acceptable means of compliance, alternative means of compliance, and certification standards. All of these are referred to as soft law. These soft law elements are really standards. They're not obligatory and therefore not laws. But in order to show that you're complying with basic regulation, you need to show that you at least can demonstrate that you are doing something to satisfy your basic regulation obligations. The difficulty with all these differing forms of regulation is, of course, enforcement. The general view is that certainly up until now, the European aviation has not had a strong enforcement regime. But this may change with the arrival of the new basic regulation, EU 2018/1139, which creates a team and structure of inspection throughout the European Union to examine whether a manufacturer or airline is complying with regulation. I suspect that it will be some time before the full effect of the regulation's intent will be felt. The more pressing part of this debate is about designors and designees. You're going to ask me, what on earth is that about? It's a good question, but an important question in the field of aviation manufacturing. The best example can be found in the recent Boeing 737 MAX aircraft crashes. In the aftermath of these tragedies, the Boeing company has come under intense scrutiny about its manufacturing processes by the federal authorities of the United States. One aspect of their inquiry centres around the use of designors and designees through the various stages of manufacturing certification that declare that an aircraft is fit to fly. In this case, it would appear that the designors were the Federal Aviation Authority who deferred their certification mandate, in other words, their responsibility to certify each part of the aircraft. They passed that role apparently onto company employees or subcontractors who, it is alleged, certified the aircraft in question as being fit to fly. This is an important aspect of aviation safety, because we take on trust that all before us have done absolutely everything necessary to ensure that the metal tube we will be flying in is indeed safe to travel on. The use of designors and designees, therefore, could be argued to be yet another extension of the soft law I have referred to. It may interest listeners to know that I have pressed the European Aviation Safety Agency on the designor-designee point, and I'll be quite honest with you, the response I have received is somewhat confusing. It appears to suggest that the same methodology exists, but they use different terminology. I have asked colleagues to help me decipher the letter, but even they are struggling with the explanation. And I have to say, I sense that this will be the topic of another podcast. But coming back to regulation, I want to draw your attention to something else that's popped up onto my radar. I understand that there is currently a small consultation being carried out by the UK Civil Aviation Authority, the CAA, into light aircraft and carbon monoxide. This follows on the heels of the tragic crash of the aircraft carrying the footballer Emiliano Sala. It appears that when the aircraft was located on the seabed, they found some very strong indicators and compelling evidence that Emiliano had in fact been overcome by carbon monoxide. As any responsible civil aviation authority would, they ordered a consideration of the issues along with a small consultation about the warning notice to be circulated to owners, operators and pilots of light aircraft. Now, light aircraft do not generally have the same environmental control systems as their larger commercial cousins. Unless they have air conditioning units installed, which for weight reasons tends not to be the case, a lower altitude and air vents provides the air that its occupants breathe. The engine operates like most aviation engines through fuel, air and of course the engineering, and provides thrust to the aircraft, and its waste products are removed by an exhaust system. The concern appears to be centred around the exhaust system and the potential for seals around the bulkhead to fail or be inadequate, presumably through concerns over maintenance. In the proposed notice, they refer to several documents, some of which are Civil Aircraft Airworthiness Information and Procedures, or CAPS for short. In one CAP they refer to, CAP 562, it defers to European law as being the principal source of regulation. But interestingly, the proposed warning notice only makes a passing reference to EU law in the other readings section. They direct the reader of the proposed notice to the section on carbon monoxide in CAP 562. It is perhaps worth reading to some of what it says. It states at leaflet B190, this leaflet describes the nature and effects of carbon monoxide, CO, and outlines the main causes of this type of contamination. It gives only general guidance on the inspections, tests and repairs which should be carried out in order to minimise the dangers of such contamination to crew and passengers. It is stipulated in the requirements that CO should not be present in occupied compartments in quantities exceeding 50 parts per million by volume for any period exceeding 5 minutes. Maximum allowable concentrations are also prescribed for other noxious substances such as fuel, oil, de-icing, hydraulic fluids, fire extinguishing agents, and the fumes given off by other materials when they are heated. It continues, when doubt exists as to the extent of contamination of the air in the crew or passenger compartments, a test should be carried out to determine the CO concentration. This test is usually carried out by a sampling process. The apparatus usually consists of a hand-operated bellows which is used to draw a specified volume of air through a sampling tube, the presence of CO being indicated by the staining of crystals in the indicating portion of the tube. That's right. To test for CO, they are recommending that you man the pumps and extract a sample into what is, after all, a glorified breathalyzer test. Now let's think about this. There's no conversation about the installation of CO alarms. There's no conversation or re-emphasis for owners, operators and pilots of light aircraft to record and report all fume or indeed smoke events. There appears to be only a reference that any remedial actions should be supported by the manufacturer's manual. As you've heard, they make reference to the holy grail of any conversation about contaminants in aircraft, chemical threshold limits. But they don't appear to recognise that the discussion around chemical threshold limits, certainly as far as aviation is concerned, appears to have reached their sell-by date. And we've moved on to a clearer discussion about sensor technology, along with a recognition of low-level exposure to contaminants. I want you to consider this also. In the USA, Congress recently passed a bill whereby operators of civil commercial aircraft will have to install CO alarms. So if there's a requirement to install CO alarms in larger aircraft, why, after the tragedy of Emiliano Sala, is the CAA not urgently recommending the installation of CO alarms in all light aircraft, whatever about their larger relations? Perhaps the answer lies in the phrase soft law, forever condemned, it seems, to allow best judgment and practice to prevail. As I said at the beginning, this international scandal has many roots, but it is the ultimate end users, the pilots, crew and passengers of whatever aircraft that has to bear the load of regulatory failure. Surely the time has come for all stakeholders, particularly state and transnational stakeholders, to recognise that we need a more intelligent approach to aviation. We shall see what happens next. Until the next time, take care.